All right, so this one says to find the slope of the line tangent to y equals cosine of x over x at x equals pi.
Okay.
Okay, so this is a product rule. This is a u over v. So why don't you take an attempt here at getting the derivative for us?
Wait, do you mean quotient rule?
Sorry, yes, quotient rule.
Okay.
I have no idea what I said.
The product rule, but then you
Product
put
rule,
u over
yeah.
v, and I was like,
Yeah.
isn't that quotient? Okay. Fine. Shouldn't it be x squared times cosine of x?
So it's the bottom times the derivative of the top. The derivative of the top is minus sine x minus the top times the
Oh,
derivative of
it's
the
just
bottom.
Oh, I wrote this in the wrong order. Okay, so it's bottom times derivative of the top minus top. Okay. Over x squared. Okay. And then you simplify that.
Okay, so do you have something like this for your derivative?
Yes.
Great. So you gotta evaluate it at pi, and that's over here to the left on our unit circle here. So you gotta evaluate both sine and cosine there. So you got minus pi sine of pi minus cosine of pi over pi squared.
Yep.
So sine of pi, that's your y value, that's 0. So this first thing goes to 0. And then cosine of pi is -1.
So 0 minus or plus 1.
Right. Over pi squared. So it just becomes 1 over pi squared.
You just leave it like that.
Yep, that is totally completely correct.
Okay.
Yeah, let's do one more quotient rule just to reinforce it.
Yeah.
And I'll just add a little bit to this problem here. We'll find dy dx at x equals 1. So again, that's a quotient rule.
Okay.
Make sure you got that down. However you want to learn that. It's but give this a try, please. How are you doing on this one?
I'm almost done. -3.
Now, I would definitely not simplify here because you're gonna just put the number in. You can, You can absolutely simplify, but it's not needed. What did you decide to do here, if anything?
I just combined, so I did 2x minus, well, first I
Distributed?
yeah.
So you got like 6x minus
Oh,
9.
wait. I only distributed to the 3. That's where I went.
Okay.
6x minus, okay, so it's 6x minus 9 minus 6x plus 4, right?
Well, this negative distributes to both. So like you get whatever you get 2
Minus
times,
4.
yeah, minus 4, yeah.
So then that's 12, negative 12, or 6 minus 6. Oh, those cancel. And then
Yep.
it's negative. Okay, so then that's negative 13. Oh, and then you just plug in the 1. So then
Yeah.
over 2 times 1 minus 3 all squared. 13 over 2 minus 3 squared. That's negative 1. Negative 13.
Yep.
Okay.
Okay, so do you know why you evaluate derivatives at a point? Do you know what that generally leads to on an exam, like what they would ask you for?
No.
Okay, so we're gonna do that next here. So you get the derivative at a point for the tangent line.
Oh, right. So you have to find like the derivative at that point, right?
Yes, so essentially some of the same stuff we've been doing now. This is a good question because it tests your unit circle. Let's just change this to, let's go to pi over 2 on this one, just to make it a little easier.
Okay.
So you do need to evaluate it at pi over 2 and then get the y value from that. So you're putting pi over 2 back into the original.
So is that one? Oh, do you not have to find the derivative?
You
of
do,
y?
but you need the point first. So for the tangent line, you need a point, which is an x and a y, and then you need the slope, which comes from the derivative.
Can we go through this one?
Yeah, we're gonna do that. I'm
Okay.
asking you to evaluate like I'm asking you to tell me what is y equals 2 sine pi over 2.
Okay, pi over 2 is 2, 1.
It's up here in the circle.
Oh, it's a sign of that sign is the y value. So 1.
Yes. So this becomes 2
2.
times 1, which is 2. Good. Okay. So now you got to take your derivative. So what is y prime?
Was that product rule?
It's just a number times a function. So it's the 2 comes with it.
So is it just
Derivative
2
sine is,
cosine
yeah.
x? You have to multiply times 2. Is that a no?
No, it's not product rule. It's just a function. And the
If that was
2,
x squared,
yeah,
would you
then
multiply by a 2?
yes.
Okay.
So you have to evaluate the derivative at pi over 2.
Okay. So that's 0. Yeah, just 0.
So your tangent line is y minus y1 equals the slope x minus x1. So your ordered pair is x equals pi over 2, y equals 2.
So it's y minus 2 equals, but what's their slope?
Slope comes from the derivative. So it's 0.
Oh, our x value is the one they give us. I see.
Yes. Yes.
Okay. And that's the tangent line?
Yeah, now you wouldn't leave it like this, like the right-hand side goes to 0. because 0 times anything is 0.
Uh-huh.
So then y equals 2.
Oh, okay. What is it? What's the one? Oh, normal is the other one, right?
Yes.
Okay.
Yes. All right. Let's do another one of these that's a little bit, I don't know, works out better, I guess. So we'll do this one right here. And we want to get the tangent line at x equals just look at the numbers here. We'll do -1.
Okay.
Okay, so I'll let you start this at least, and I'll check back with you in about a minute. See how you're doing.
So
All right, how are you doing on this one?
so I found the point and the derivative.
Okay, so you plug in -1 in for x.
I
Just gotta
got
be
-1.7. That's the point. Oh,
okay. First point is -2, or this becomes -2. Seems -3 plus 12, so I get yeah, 7. I get +7.
okay. Yeah.
And then the derivative.
I got 6x squared minus 6x minus 12.
Okay,
And then I forgot what you do next.
you need the slope, which comes from the derivative, so you
Oh,
evaluate
you
the
just plug
derivative.
the point in again? Okay, that's
Yeah.
what I thought. So it's that squared 6 times -1. So that's 6 minus plus 6 minus 12. It's 0.
Wow,
Yeah.
I didn't see that coming. Okay, well, it's essentially the same thing.
So then it's
Uh,
y minus 7 equals 0, x plus 1, and then it's y equals 7.
Yeah. Okay, so let's just say you did this problem the way it was originally intended, and you got this as your tangent line right here. Okay, if this is the tangent line, the normal line, the only thing that changed with the normal line is this right here. This you have to do the opposite reciprocal.
Okay.
So this becomes -1/6. The rest of it is exactly the same.
Okay. Okay.
All right. I guess we can look at this question. It's probably a good question to look at. This is like a backwards question. It gives you the slope. It says find the points where the slope of a line tangent to the curve is equal to 6.
Okay.
So they're giving you the slope, and you have to take the derivative. You have to find f prime or y prime, and then you set it equal to the slope.
So y prime equals 6x squared.
And you set that equal to 6.
6x squared equals 6, divide by 6. X squared equals 1, so x equals plus minus 1.
Yes.
Okay.
And that's it for that one. So let me see if there's one right good here. Oh boy.
Wait, so that's all they want this plus
That's all
minus
that, yeah,
one?
that's all they want. That's all they want for this one.
Okay.
Okay. So your instructor likes these piecewise graphs. So
Yeah.
let me use this and kind of make up a question here. Let's find the tangent line at x equals 1. So you gotta figure out which function you're gonna use, because you're gonna have to find the point, and then you're gonna have to find the derivative to get the slope.
Okay, so x equals 1, so you have to use the first one,
Yes.
and then just plug in the point.
Yep. You got to plug
Was
1
this
in
2?
to get the y. Y is 2. Okay, good. But the tangent line, again, requires two things. It requires a point, which you now have, and the second thing it requires is the slope.
Oh, okay, so
Comes from the derivative.
y minus 2 equals.
So what's the slope? You've got to find the slope of this. What's the derivative?
2.
Yes, derivative is 2.
2x minus 1. You want just do I simplify that or leave it in point slope?
You leave it in point slope. So you get y minus 2 equals your slope 2x minus 1.
Yeah.
All right. Now let's do something different. I want the all right, I want the normal line.
Okay.
At x equals -1/2. And let me just copy this down.
So do you do that whole process again with that point and then just do opposite reciprocal?
Yes, but you're gonna use a different, function.
Yeah, exactly.
This time, yeah.
So -1/2, that would be the second one. So -1/2 squared plus 1. 1/2 squared is 1. 1 plus 1 is 2. And then so but the derivative is 2x.
That's right. See, f prime of x is 2x. So you have to take
Oh,
your x.
Yeah, okay, I remember now.
Yes.
So then that cancels. So it's -1. Okay, y minus 2 equals -1 x plus 1/2.
Did you put -1/2 back into this to get your y value?
Yeah.
So it's -1/2 squared plus 1.
Mhm.
So that's 1/4 plus 1, 5/4. I heard something different.
Oh, wait. But a half plus.
You're squaring it though.
Oh, yeah, that's why. Not times 2.
Yes.
Okay, so that's okay. Y minus 5/4 equals -1. Okay, the rest I got right.
Okay, this is the tangent line though. So how do you change this to make the normal?
Oh, so it's just y minus 5/4 equals 1, is it just 1?
Yes.
Okay. Yeah. So if it was like, if it was 5/4, it would become -4/5, right?
Yes.
Okay.
All right. Let's do a product rule, if
Okay.
that's okay.
Yeah.
So this one, it's pure like, do you know how to do it? Do you know the rule? U times V. It's U times V, but it's got quotient rule inside of it.
Oh, and I also asked him about the like table, if there would be like any problems where he'd give us a table, and he said there could be. So
Okay. All right. Maybe for derivatives.
yeah, I
Or-
think so.
All right. We'll give this one a try, please. So I'd like to at least check with you on the first one.
Yeah, just 1 second. Okay.
Actually, this one does not have any quotient chain rule. It's just got pure power rule inside there.
Yeah, I got that first part, and then I got 3x fourth minus 4 times 6x squared.
Perfect.
Okay.
Okay, great.
Now I can simplify. So do you distribute the 12x cubed to both of those?
I would just leave this. We're done. Well, this is done. This is just like kind of an in-between problem.
Oh, you just leave it like that? Okay.
Yeah, you can just leave it like that. So let's go back to some tangent line stuff. This is a good problem I see here. It's perhaps confusing. So this is it's saying let f of x be a function, f of 2 equals 3, f prime of 2 equals -5, and g of x equals this. This is the thing that you're evaluating. Okay, even though it looks weird, like you have to put 2 in for x. You need to find g of 2. G of 2 is x times f of x. So it's 2 times f of 2. That's where this one comes in. So it's 2 times 3. So now you have your ordered pair. When x is 2, g of x is 6. So you have your ordered pair, because we're trying to find the tangent line.
So, okay.
So now though, you have to take the derivative of g prime of x.
But you don't know g prime. You don't know what g of x is.
That's right, but you know that it's x times f of x, so you can use product rule.
Product rule on what? On the
X times f of x. So x is like u, f of x is like v.
Okay, so it's
Keep the first.
x times f prime of x.
Yep. Plus
f of x times x.
Derivative of x is 1. Yes. And then hopefully you know these values, and you do. You know that x is 2.
2 times f prime f -5 plus. Where'd you get the 3 from?
Right here, this Boxton, f of 2. F of 2 is 3.
Oh, okay. And then times 1. Yep. So then that's -10 plus 3. So that's -7.
Yes. So this is your slope.
Okay. So then it's y minus 6 No.
Yeah, that's y minus 6. That's your,
Oh, yeah.
that's
Equals
equals,
-7 x minus 2.
yes. Okay, so let's try this same problem now, but it's going to be a slightly different derivative. We're going to make it x over f of x.
Okay. So
So it's the same question. You got to find g of 2, but it's now x over f of x. And then you got to take the derivative of this using quotient rule.
So then 2 equals 2 over 3. 2/3. Is that right? 2/3 for g of
Yes.
x?
Yeah.
Okay.
So the point is 2 comma 2/3.
Okay.
Good.
Let's make sure. And then it's quotient rule, right?
Yes.
So bottom times derivative of the top is x, or no, 1 minus x. F of 2 is 3 times 1. X is 2 times -5. Squared. So that's 3 is 10. Is the slope 13/9?
Oh, let me get caught up to you here. Because it sounded pretty good. So it's the bottom times the derivative of the top, which is 1, minus the top times the derivative of the bottom, all over the bottom squared. So we'll put some numbers in, but we're doing it for, sorry, this is g prime, doing it for 2. So we need f of 2, which is 3, times 1, minus 2, f prime of 2 is -5. So that 13 up top is looking pretty good. And then f of 2 is 3, so that's 9 on the bottom. So I think I heard 13/9.
Yeah.
Yes.
So that is y minus 2/3 equals 13/9 x minus 2.
That's right. Now, if you wanted the normal line, what would be the change to this?
Y minus 2/3, -9/13.
-9/13, yeah.
Yeah, x minus 2.
Okay, great. All right, so I feel like we've covered everything on the quiz. I'll just move more towards the
Test.
test. Yeah. So there was this question on velocity. Maybe we just do our own sort of analysis review on this. So they give you a graph of velocity. A velocity is the derivative, because they could give you a derivative graph. So when the velocity is above the x-axis, it's the position is increasing. So position is increasing.
Okay.
When the velocity is below the x-axis, the position is decreasing. So you can think out of it. Increasing means like you're getting further away from home. Decreasing is either getting closer to home or going backwards. But that's the first thing we can look at. So
Okay.
when velocity equals 0, it's not moving. I guess that's another thing we could talk about. But like when the velocity equals 20, like it does here in this region
Yeah,
here.
that's what I
That
got
means
confused on.
so that's not the right word. When the velocity is horizontal, that just means it's moving at constant speed.
So is it not, where would it ever be not moving?
When velocity is 0.
Oh, so is that 9? Okay, gotcha. 9 and
Yeah.
15. So it's increasing from 0 to 9, and
That's
then
right. Decreasing from 9 to 15.
Yeah, 9 to 15, and then increasing from 15 to 18.
Yes.
Not moving from 9 or at 9 and at 15, and then
Okay, so now we can talk about whether something is speeding up or slowing down.
so is that slope?
Yeah, we have to look at the slope. So it's speeding up if velocity is positive and the slope is positive. Or, this is the wrong or. Another case is that velocity is negative and slope is negative. So they have to both be true.
Wait, both? It has, what do you, oh, so these,
So these are ones like from 0 to 2. Do you see that the velocity is positive because it's above the x-axis and the slope is positive?
yeah,
Okay. And then velocity is negative here.
but that's so weird that that's speeding up.
Yeah, because speed is the absolute value of velocity. So it doesn't
Oh,
care whether it's positive or negative.
I see. So, okay, so those two, and then is slowing down.
So slowing down is, see how these are both like speeding up, they have to both be going in the same direction. It's now like they work against each other. So if velocity is positive, but the slope is negative.
So 7 to 9,
Yes.
and then
Velocity is negative, but the
14 to
slope is
15.
positive. Yes.
No, 14 to 16, right?
Uh, it's
Oh no, no,
only,
just
yeah, 14 to
14.
15. Yeah.
And then 15 to 16 is pot or speeding up.
Speeding up. Yeah.
So then what is from 2 to 7 and 16 to 18?
If velocity is horizontal, it's moving at
Oh,
constant
okay.
speed. So it's neither speeding up nor slowing down.
Okay. Okay.
Do you want me to give you a graph like this to try to figure out some things on your own?
Yeah, sure.
Okay. All right, so we're gonna call it A, B, C, D, E, F, G, and H.
Okay.
And I'll be right back in 30 seconds. All right, so anything you want to tell me, like what's going on from A to B, or any of these, do you want to tell me like what you see happening?
Okay, so I only got one so far. So speeding up from A to B,
Okay,
C to D, and F to G.
yes, that is true.
Okay, and then slowing down from, well, I didn't get this far. Down from B, or yeah, B to C, E to F, and G to H.
Yes. So
And then
what's happening at C, F, and H, and then what's happening from D to E?
C or D to E is constant.
Okay,
C, F, and H are not, or what's it called? Not moving. I don't know.
that's
what
right. Yeah, velocity is 0, so it's not moving.
Yeah. And then what was the other one? Increasing, decreasing. So decreasing from A to C and F to H, and then increase
Yes.
from C to F.
Perfect.
Okay.
All right, let's move on to a new question here. All right, a particle moves along the x-axis and it's given by this. So what I want you to do is find both the velocity and then the acceleration.
Okay.
There are two functions.
Are you asking what they are?
Yeah, whenever you're ready, just give me those functions.
Oh, I remember. So v of t is 6t squared minus 18t plus 12, and then a of t is 12t minus 18.
Okay, so I want you to set them both equal to 0 and find where they equal 0 for each of them, please.
Um, 6t squared. Oh, you have to factor it, huh? Okay.
Yes.
Oh, I kind of forgot how to factor when it's not. Oh wait, I can do this. Okay.
You can almost always factor out the first number.
Yeah, that's what I
they're
was just
designed
gonna
that way.
do.
Yeah.
I was like, I forgot how to factor when it's not a equal. Okay, and times 3 times 2 equals 0. Mm. 6. T minus 1, so t equals 2 and 1, and then 12t minus 18. Yeah, I got 2 and 1 and 3 halves. Yep.
Perfect. Okay, so now let's make some sign charts. We'll make one for V of t. Now it does start at 0. You don't have to go forever. So it's 0 out to infinity. And we'll put those two critical points in there, 1 and 2. And then we want to decide whether it's positive or negative in each of these intervals. Do you remember how to?
It's only one. It's only 3/2 for the A of t, right?
That's right. That's
Okay.
right. And we'll talk about that in a moment. But what I'd like you to do is test a value, and you want to test it in the factored form. So like your V of t was 6, t minus 2, t minus 1. You want to test that these whatever values you pick. This is 0, 0, like something like 1/2, 3, 1.5, and then 3 maybe. But I'd like you to give me the signs for each of these.
Okay. The 0 to 1 is positive.
Okay.
And then this one, 1.5, that'll be, that's negative, that's positive. Positive. So that one's negative.
Okay. Good.
And then the 2 will be positive.
All right. Very good. So now for A of t, you want to draw the same kind of sign chart and at least have like the position of 3/2 be in the right place relative to the other ones. So I'd like you to, look at that one, look at 6 times t, 2t minus 3, and tell me, is it positive or negative in this window, in each of these intervals, please.
So the 0 to 3/2 is negative.
Yeah, so maybe try 1 there.
And then the other one will be positive.
Good. Okay. So now there's really like, if I draw some dotted lines, it's like 4 regions. There's region 1, region 2, region 3, and region 4. So what is happening in region 1? In region 1, the velocity is positive, but the acceleration is negative. So velocity is positive, acceleration is negative. Is that speeding up or slowing down?
In velocity is positive. Wait, I need to think about, okay. So it's speeding up because they're like
it's only speeding up when they're going in the same direction. So when I said slope is positive here, that means acceleration is positive.
Oh, okay.
And velocity is negative, acceleration is negative. And so A and V have opposite signs when it's slowing down. So here it's
Okay,
slowing
so
down.
it's region 1 slowing down, region 2 is speeding up.
Velocity is negative and acceleration is negative. Yeah, it's speeding up.
3 is negative, positive, so down. Yeah, down.
Slowing down.
And then pause. So
positive and positive. Yeah, so it's speeding up. So it's actually the same analysis as a graph. I think the graph's a little easier.
Okay.
Great. Okay, let's look at something else here. That we can't do that because you don't have a calculator. Okay, so I want you to just
for the multiple choice, there's you said 15, no, 25 no calc, and then 15 calc.
Okay, so I want you to find f prime of pi for this one. And it's a pretty good derivative. Like you gotta use product rule in both. Let's see if I can get it where, yeah, there we go. You gotta use product rule in both, and then you evaluate it at pi.
So
go ahead and take your derivative, and then I'll check you in a minute or two to see how you're doing. All right, so how are you doing on your derivative?
let me make sure I got the same thing. I got x cosine x plus sine x plus x sine. Yeah, I got the same thing.
Excellent.
So then
Okay.
do you do cosine x squared? Is that what that becomes?
Nope. I wouldn't combine anything out because we're just evaluating it, but no, like
Oh.
yeah, don't just, so it's pi cosine pi plus sine pi plus, well, or minus, let me do a minus there, minus pi sine pi plus cosine pi.
So it's negative or pi times -1.
Yep.
Plus 0.
Yep. Minus pi times 0 plus -1.
Yeah.
It's ended up being minus pi minus 1. I have been skipping some of the like calculator problems, so just maybe tomorrow, when I know we're meeting on Sunday too, like maybe we can look at some of those.
Okay. Yeah, because majority of it is no calc, but there is.
Yeah. All right. Well, that takes us to the end of our session for today. Thanks so much for scheduling. I'll send you the notes out shortly, and I'll see you next time.
See you tomorrow. Bye.
Bye.